Sooner or later in your job as a game developer in Unity, you're going to come across raycasting. Raycasting is a way of firing a virtual laser beam through your scene and finding out what it hits. And that beam can penetrate multiple objects. Now in our project, we're going to use that to determine what the cursor is effectively over. So we're going to look through the camera, straight into the scene, at the position of the cursor and say, hey, what's here? What am I hitting? And we're going to use Unity's layers. So we're going to have things like an enemy layer, we're going to have a walkable layer, and we're going to allow that to determine whether something, when we click on it, is whether we can walk there, or whether there's an enemy at that position, etc. And something Unity is going to ask you for when you raycast is a layer mask. And that's an integer that it uses to determine, or a bit mask, which I'll explain in a minute, which it uses to determine which layers it cares about when it's interrogating and firing through the scene. This is a filter, basically. Very simple. So, firstly, you're going to see a line of code like this. Int layer mask. So we're going to define an integer called layer mask, or we can call it what you like. We're calling it layer mask. Equals 1 bit shifted left by the layer number that you want to be looking for. So we're taking a layer number, we're making sure it's an integer, casting to an integer here, and we're taking the number 1 in binary and bit shifting left. What does that mean? Well, if the layer was 0, then the layer mask would simply be this, because the number 1 in binary is what you see on the screen here. Lots of zeros. I've left out all the middle zeros because we've got a 32 or 64-bit integer here. You don't want to see all those zeros. But what it matters is the last bits over on the right-hand side here, the least significant bits. And that is just the number 1 in binary, bit shifted by 0, so not moved. Okay, so that's not bit shifting. So what happens when you bit shift by 1 place? Well, your 1 just moves 1 place left. That is a leftwise bit shift by 1. And if you were to bit shift by 2, then this would happen. You would shift the 1 2 places. All right, etc. So I think you get the idea. The layer mask ends up being a 1 in the column that determines the layer, counting from 0. So this is column 0 on the right-hand side, and then column 1, then column 2, etc. So why do we do this? Why do we care? Well, you can tune out now and move on to the next video if you don't care, but if you want to know why this is done, then behind the scenes, Unity is almost certainly doing a bitwise AND at some point. So it will have some sort of hit layer. In this case, this is layer 1. And it's going to do an AND with our layer mask. And if our layer mask says 0 like this is the layer mask for 0, remember, from the top line above, then we get a false. Because if you take an AND of each of these bits together, you don't get any hit. There's no case where the 2 bits line up. We have 0, 0, 1, 0, trying to sit over the top of 0, 0, 0, 1, and in no case are they both 0 if you put those two on top of each other. But on the next line, if we have a layer 1 hit layer with a layer 1 layer mask, then the ones sit on top of each other. You get a true back, and this means, yep, we have a hit in this case on a layer that we care about. So it's a very quick way of the machine down on a silicon level of saying, yes, I did, or no, I didn't, get a hit on a layer that I care about. That's the question it's trying to answer. Did I get a hit on a layer that I care about based on the mask? Now, you could have a more complicated mask that has multiple bits set, but let's not worry about that. These are the basic principles, so when you see that shortly, hopefully you'll be well equipped to understand a little bit more about what a layer mask means.